So the first file I want to look at is app.txt here because it is still allocated. It's pretty much just a normal file. If you were to mount this image as a file system, it would still show up and you'd see it just like this. You can see that FTK Imager has decoded it. It looks pretty much like it does in the answers section if you downloaded that and took a look at it. Although it does also contain pieces of the pancakes and meat pies section. So that's a little bit interesting that it's mixed in there sort of randomly. This is just a part of the scenario that has nothing to do with the way that the file system adds these things in, so don't get too confused or worried about that. If you'd like to see the relationship between where each of these files are and what sections of the menu they contain, then take a look at my answer sheet I provided. It goes into quite a bit more detail than the one that comes in the scenario. You can also look at app.txt in the hex view here, just like the others, and you can see it's a lot more spread out. You can look at the raw data and notice that each of these letters has a little dot after it. And I'll get into that in a little bit. That has to do with the encoding system used here, which it mentions specifically in the scenario. So next up is this unallocated exclamation point 4b0 tilde 1.txt. I believe the reason that the file name looks so funny is actually to do with the fact that it may have been a temporary file. Not all deallocated files are going to obtain a weird name simply because of deallocation. And you can see with this one, it's also been decoded properly. It looks pretty much right, and it contains the beverages section all together the way that it should be. Next up, we're going to take a look at the file slack for this same file. I already explained what file slack is, so if you just take a quick look at it, you can see it has meat pies and dumplings, a little bit more of that meat pies section. And in this case, you cannot convert it straight into text, so we're going to have to figure out how to decode it. The first thing that you want to do is grab all of this data here. You can just highlight it all, right click, and copy hex is what you want, because if you copy the text, it'll try to copy exactly what you're seeing here, which is what we're trying to fix. Next step is to go to CyberChef. Really, you can go with a number of different platforms for this, but I think that CyberChef is really the best option for dealing with different data types and decoding them. And you don't even have to install anything. It just pops right up here for you. So first thing we do, you've got input here, paste all your data into that. You can see output is exactly the same because we haven't told it what we're doing yet. You need to take it from hex, that way it knows what kind of data you've got here, and you can see it's already outputting the same ASCII text that FTK Imager does. So that tells us all we got to do is decode the text now, and thankfully you can just search up here the word decode, which is what is so great about CyberChef. Drop that in there, and it's decoding it as UTF-8, so I wouldn't expect it to really work right. And you can see it didn't. But if you look at the scenario, UTF-16BE is what we're working with. And there you go. You've got this Cyrillic section here that translates to meat pies and dumplings. And then you've got pirog and pirozhki. And that's meat pie and something else that we'll have to find by putting it all together later. The reason when you were looking at it as ASCII or UTF-8, you've got all of these dots in between is because of this number here. 8 means that there are 8 bits for each letter. That is 1 byte. In UTF-16, that means that you've got 2 bytes per letter. So going back to FTK, if we highlight the M and the dot after, you can see it's 0. English letters only need 1 byte per letter, and that's just because they came along first. It's the same between ASCII and UTF. However, for the Russian letters, you're going to need to decode it because those were added later on as UTF and ASCII were expanded into UTF-16, 32, and so on. So the next one we've got to look at in this file list is this a7-1.txt. It's unallocated and it's also completely empty. Try looking at the hex version of it. It still doesn't actually interpret anything. The reason for this is that it has an entry in this root folder that we're in, but there's nothing there. It may not even have a position. The root directory may not be telling FTK where this file's at, just that there used to be a file called A7. But it's empty now, and FTK is just letting you know that it was there. Next up, we can go into this unallocated space folder and look at 0003, and that is just our beverages section again, which we've already seen. The reason that it shows up there is because, if you remember, we saw that in unallocated space. So it's not that there are 2 of these, it's just that FTK has 2 ways to show it to you. Next we look at this 06 one, and it's just a lot of B9 hexadecimal. I believe what's happening here is if you look at the scenario, they actually overwrote a lot of the disk with B9 rather than just zeros like you might expect. And I believe FTK is interpreting that to be something because it isn't just empty data. These files that you have here, 3 and 6, are actually named based on the cluster that they begin in, and you can see it at the bottom here, cursor position 0, cluster 6. And if we went down further, then we would start in a new cluster, that's 7. A cluster is 2 sectors in this case, but we'll cover that later.
Next up is the unpartitioned space. This is space that doesn't have a file system. You can think of it like slack space for the entire disk that you're looking at. It's one way that people tend to hide data on a disk is they will partition it into a few different sections and leave some data in the unpartitioned space. This MBR here means master boot record. That's just telling your operating system how to boot up this disk. It doesn't really do anything in this case since there's nothing on here. However, there are hidden data from this exercise, and you can see when you click here, we got all these B9s again, but click text, and there we see we've got borscht cabbage soup. So it looks like it's going to be the soup section here. Problem is, we don't really have the Russian. It's decoded it as ASCII, and it's rather funny looking. Also, this is a lot of data here, so your computer may stall out of it on it. Anyways, it doesn't tell you exactly where this stuff is, so you will have to find it. Luckily now, we know that we can search for these words, because in the scenario, we don't know what the menu contains. You can always just look at the answer section and cheat and search for these words, but I'm going to assume that you don't want to do that. So we copy this word, and then we head back to our hex view here, and right-click, and find. You can search ANSI and Unicode by searching for text. So you want to do that because this is UTF-16, which is a form of Unicode. And even though it doesn't show it to you, FTK does sort of know that. And you can see it worked. We found borscht. So this appears to be the beginning of the soup section. Let's just take all of the data and decode it just like we did before. We will copy the hex, we will go back to CyberChef, and just paste it in place here if you've still got the recipe. If not, it's from hex, and then decode text is UTF-16BE. So once we have that put in, we hit enter, and you can see we get our soup section down here. Up next is this 144585, and by the way, these are also named based on their sector location from the beginning, but it's the beginning of this unpartitioned space this time. So you can see right away we have meat and fish and a host of other things, so we just decode that just the same. Take a nice big chunk of everything that you see, and there we see B9 starts up again, so that'll be the end of it. Copy our hex, put it over here, paste it in, enter, and we have meat and fish. What you don't see easily here is that this actually also contains the cheese and milk products section and the dessert section. But you'd have to scroll through it for quite a while. Hitting text on this one doesn't do anything like it did for section 1 over there. So, assuming that you knew that, or you knew what the sections were called, you could just do a text search from them for them, but the scenario is that you don't. So we will have to find them later by other means. And that is what this next section is about, finding files with hex-based signatures. So, how are we going to search for these remaining sections without knowing what they're called or what's in them? Well, there's a couple of different things you could do. You could create your own custom search with a script. However, you can't do it with FTK Imager. It doesn't have any special search functions aside from what you've already seen. So in order to run a script on it directly, you would need the raw image file, which is a DD file, which you can download. But there is a significantly easier way. You probably noticed by now, or if not, I can't really blame you. Most of these sections with any text begin with a little marker here. And it is this little thing, interpreted as B with a little tail on it and a Y with 2 dots over it. And if you highlight it, you'll see that it is FEFF in hex. So it seems to be related to the UTF encoding. So I did a quick little Google search, just the words UTF followed by FEFF, and what do you know? It turns out it is known as a UTF big/little Indian marker. Big and little Indian refers to whether the larger of the two values of a number comes first or second. So in normal decibel numbers, let's say you have the number 70, it is little Indian because 7 is the number that represents the tens place. 0 represents the ones place only. So 9 in the ones place is never even going to be as big as a 1 in the tens place. It is a little Indian. That's spelled E-N-D-I-A-N. So in this case, the fact that it says F-E-F-F rather than F-F-F-E tells you that this is in fact Little Indian. So that's not really the information we need. What we need is just the fact that this value here is going to be included in all of this because it's encoded like that. So we can copy the hex data, and then we can go to the entire image here. Clicking on t.eo1 up here gives us everything in our hex viewing window. So we can do Control F, or you can right click and then do find, but it brings up this search just like we did earlier, and this time you're searching for binary, and we will paste in our value, FEFF, and click Find. We're starting from the very top. It starts from wherever you have the cursor. So if I put it up here and hit F3, which finds the next one, it goes right back down to where it already was. There's the soup section, which we've already seen. There's appetizers. We got pancakes, which was inside of appetizers, as you may recall. Beverages, meat and dumplings, meat and fish. There was the one that we did not see earlier, one of the two. So you can copy that, do the Unicode, UTF-16 decode on it through CyberChef, just like before. Let's keep searching. Cheese and milk products. And finally, dessert. Yum yum. What these Russians consider dessert is not all exactly what I'd want, but what are you going to do? So that is all of the sections. The one thing we didn't find is parts of the pancake section, starting with pancakes with sour cream and ending with the Russian words blini s selodki, which I believe was pancakes with everything. Yeah, it was part of pancakes with everything. Selodki means herring, but it repeats it because it says that and then lists all the other things that make up everything. And the English translation just uses the word everything. So I've searched all through this using the answer key just to make sure, and I never found any evidence of the rest of the pancake section. Let me know if you find it, but I think it just got overwritten by other parts of app.txt. Another way that you could do a search if, let's say, this encoding did not appear from the beginning of each of these sections, the FEFF, one thing I thought you could do is take the DD image, that's the raw image once again, and run a quick script that deletes any values that match B9, because that is all of our big empty sections. You could put that through CyberChef and look for all of the UTF-16 encoded stuff, strip away things like the MBR that we saw earlier. Should be pretty easy because those would not come out to be words. Like I said, not really necessary in this case because we have this one indicator that happens to be present for everything, and it really solves all of our problems. So next up, what I'm going to show you is how to actually parse the file system yourself. Now, this is not a part of the scenario. You don't have to do it, and if you feel like just ending the video now, that's fine. The reason that I'm showing this to you is to help teach you how to learn Hex. It lets you verify your tools and make sure that what they're telling you is in fact the truth. If you can look at the raw image and make sense of it. It also just teaches you a little bit about file systems. This is the FAT system, which is not the most common. Anything bigger than a small USB drive is probably going to have a different file system. But this is, in my opinion, valuable to at least be familiar with. I wouldn't recommend you necessarily follow along all of the math with me. Just get an idea of the sectors, the clusters, what makes up the file system, because those are relevant in forensicating any disks you have that happen to have this file system on them.